हाय गाइस, वेलकम टू कोडिंग वर्ल्ड। सो पिछले वीडियो में हम लोगों ने देखा था रिकर्शन क्या होता है। रिकर्शन पे दो मैंने प्रॉब्लम्स करा दी और बता दिया कि रिकर्शन कैसे वर्क करता है, बेसिकली हाउ इट यूजेस इस स्टैक यू नो। मैंने फिबोनाची नंबर एंड फैक्टोरियल करा दिया। now it's time, now guys, it's time to solve some advanced type problem. So I'm starting with medium level problem. Okay, see what is, so I have written a complete C++ code, you can see here. Okay, see what I'm trying to say is, now listen to me very carefully. Okay, suppose what is this is saying. Suppose in tree data structure, suppose there is a tree, like suppose there is a tree. Suppose there, here it is, say it is R, it is O, it is H, it is I, and it is T. Say R has two children, O and H. O has also two children. See, O has also two children, that is I and T. And say I has no children, that means null, it is also null. T has also no children, so it is null. And H has also no children, so it is null. See, R has two children, O and H. O has also two children, I and T, and the rest of are null. This is the last, the last branch. You can see the last, this last level has no children. This is known as leaf node, where there the leaf nodes are that node. See all are called as nodes. See, all these all are nodes. But see, what I'm trying to say is, all these nodes which do not have any children, they are called as leaf nodes. See, R is a leaf node. No, it is not a leaf node because it has two children. H is a leaf node. Yeah, it is a leaf node. Why it is a leaf node? Because it has no children. Does O is a leaf child? Is a leaf? No, it is not a leaf node. Why it is not a leaf node? Because it has two children. T is a leaf node. Yeah, T is a leaf node because it has no children. Isn't it? The node which does not have any children, that is called known as leaf node. It is, isn't it? Are you getting my point? Suppose what is the left of this node R? The left of the O is at the left of this R, and H is the right of this R. So you can see, are you getting my point? So in this way, suppose this is a tree. This is actually a tree. Okay, this is a BST, or you can say binary tree. BST, also discuss about how to discuss what is BST. We will discuss in tree playlist. But see, this is a tree, and in order to traverse the tree, we have different types of tree traversals. First one is, here I'm writing, first one is in order traversal, second one is pre-order traversal, third one is post order traversal. In this video we are going to discuss only about in-order traversal. See, what is in-order traversal? See, here I'm writing what is the in-order traversal. In-order traversal, first we have to print the left part of a particular node. Suppose if I'm doing the in-order traversal for this only part, that means ROH, then definitely I have to print the left, that means O. I have to print first O, and then I have to print the node, and then I have to print the right of that to this node, to the right of this node. See, what is node? Node is R. What is right of to R? That is H. So this is the complete answer for only this part. Suppose if I'm doing in order traversal for this whole tree, then go to the R, given a node, we have to go to the left. See, now let us discuss how it is going to work. Okay, so I'm erasing this. I hope you are you can make a note of this. Okay, now I'm erasing this. See, here I've written a C++ code. So you can imagine that you have to create a class of a structure, in which you will have basically this many as character. This is called as character, and then you have to two pointer, that is a struct star, struct star left pointer, and also this is a pointer, this is a right pointer, in this way. And this is the function for in-order traversal. See, we cannot traverse tree without in-order. We cannot traverse tree in any order. We have to traverse in a particular way, and programmers have given us many way to traverse the tree. The first one is in order, and I will also discuss about pre-order, post-order, double order traversal, triple order traversal. There are many kinds of traversals. The first one is in order traversal. Now I am discussing what is called in order traversal. Let's see. let's see. So suppose we have a tree, suppose we have a tree that is A, B, C, D, E, and here I have F, G. See, you can say that this is our null. Why this is? Because there is no children to this, so they are known as leaf nodes, isn't it? Are you getting my point? See, why I am taking this example here, this programming example here, because I'm, it, with the help of this I will, I will make you understand what is the beauty of recursion, how recursion beautifies our mind and coding problems also. Okay, we'll see lots of tons of problems in upcoming videos also. Okay, now let's see, start. Suppose this is known as node. See, what does it do? It links to its A, node A links. Node A क्या कर रहा है? Node A अपना दोनों children का link अपने पास में रख रहा है. It you can imagine as a as a kind of linked list. So A is connected to B and C. B is connecting. So ultimately A is connected to D and E. Anyway, via V, isn't it? Are you getting my point? Suppose if I know the address of A, say A as an address of 100, and suppose T is nothing, you can say struct node start T is a pointer of type struct node. Struct node is, you can say, also you can write here as a node, and here also I have to write a node. Basically C, this is a C++. You can also get this code from anywhere. Okay, I have the main function is this. Now try to understand me, try to try to grasp this concept. Okay, now T is pointing to 100. Suppose in variable T I am getting the address of this node. Suppose end user has created this tree, isn't it? And you got this tree, and what end user wants from you to traverse this tree via in-order traversal, isn't it? Now in T I have the address to A. Okay, is T is equal to null? No, T is not null because T has two children, so this condition is not satisfied. I will enter into the else if part, and see, I'm marking it here. It is 1, it is 2, and it is 3. See, this A part, I'm erasing all these things. Okay, yeah. See, now try to understand what I'm trying to say. It has to execute these 3 statements, but as soon as first, so it will execute in a sequence wise. So first it will execute this first statement which says in order T ka left. So first it will execute the one part. So as soon as it will try to execute this first part, it will again going to call this function in order, in which what it will going to pass, it will going to pass T ka left. That means it will going to pass B. Now B, from here control has come here, and it will again going to because see, here it is checking that now in T I have the address of B. Is T null? No, T is not null. So I have entered into the else if part, and see here it has also execute these 3 statements one by one. It will execute. Now it will start executing first statement. What says? It says go to T ka left. Now go to D. It is again going to execute these 3 statements 1 2 3. See, let's check. Now D, I have passed the D. Is T equal to null? Now in T I have the address of D. No, T is not null. T has some data, isn't it? Are you getting my point? Now it will enter into the LC part. T not equals to null. That's why I'm entering into this. Here I have written T is not equals to null. T is not null. This is null. D ka left is null. See, the left of this, the left children of this D is null, but D is not null. Are you getting my point? Okay. Anyway, this has also been discussed in my tree data structure playlist. So if you are not comfortable, then go and watch tree data structure playlist. Now see, it has execute 1 2 3 statement. Now first it will try to execute 1. So as soon as it will try to execute the first statement, that is passing the T ka left, that is null, so it will return nothing, anything. Now it has so from D, so this will again this will again give back the control to D. Now D has executed 1. Now it will execute 2 statement. What it says? It says cout T ka data. Now T ka data is D. Are you getting my point? It will execute second statement. Now in output section I am writing what I am getting. I am getting D as output, isn't it? Now it will try, now from it and now it will try to execute this third statement, which says again go to in order T ka right. Now T is D. It will again go to the right. Now from D again control here comes back, isn't it? Are you getting my point? After execution of 3, it says in order TK write. Now TK write is again null, so it is null, so it will return nothing. Again control will come back to D. Now D node has executed all the statements. Now it will give the control